Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by preparing the environment and data. Install Python 3. 8+, set up a virtualenv and pip install NumPy, Pandas, scikit-learn, and Torch if needed. Once done, pick a dataset and split it into train, validation, and test sets. Use stratified splits for class balance. Next, choose a baseline model and commit to accuracy as your primary metric for now. This focuses the pipeline. Make sure to version data and code so you can reproduce every experiment. You now implement preprocessing and training, scale numeric features, one-hot or labeling code categories, and impute missing values. Then train with k-fold cross-validation to obtain robust accuracy estimates. Log both training and validation ACK and loss per epoch so you can spot overfitting. Once predictions are available, calibrate thresholds for probabilistic models, and compute the confusion matrix to understand class-wise performance. Along the way, save the best checkpoint and artifacts. You finish by evaluating the model on the held-out test set and reporting final accuracy plus variability. Use bootstrap or cross-val variants when necessary. Export the production-ready model, wrap it in a minimal inference API, and set up monitoring to detect data drift and accuracy degradation in real time. If accuracy is lower than expected, investigate common failure points: data leakage, incorrect labels, class imbalance, insufficient model capacity, or poor preprocessing. Address one at a time and rerun experiments.
Thanks for watching. Subscribe to keep your life in tune.